Hello students, our environment is full of mysteries, mystery of scientific phenomena, and the key to unveil this mystery is to put right kind of question. And if you can put a right kind of question, you can solve the mystery of this universe. Keeping it on note, let's continue today's discussion. Earlier, you have studied about atoms in lower classes also. Looking in our surrounding, we observe there are varieties kind of matter, one different from the another. The question that comes into mind, why one substance is different from another substance? There are 118 elements are there. What makes the atom of one element different from the atom of another element? This question forced us, the scientists, to think and experiment to understand these properties of matter. Are atoms really indivisible as proposed by Dalton? These all questions started giving a way for other scientists in order to do experiment and to find out the truth behind it. And with the advancement of science and technology, they could find it out that the atom that we were studying as an indivisible particle is actually not. And discovering the characteristics and properties of atoms helped us to understand the properties of different matter that is surrounding us in our environment. And what was that key to unveil that mystery? That was the discoveries of the charged particles. As you know, an atom is not merely indivisible. It can be divided further, or it consists several other subatomic particles like electrons, proton and neutrons. So discoveries of this particle helped us to understand the exact properties of the substances we see around us. So let us come and see how these particles were discovered. Electron and protons were discovered much earlier, but neutron was discovered much later. For a fact and for your information, electron was discovered by J.J. Thomson, proton was discovered by Goldstein, and neutron was discovered by Chadwick. So here is one video that will show you how your electrons and proton were discovered. The electron and proton were discovered by an experiment called as discharge tube experiment. So let's watch that video and find out how these electrons and protons were discovered.
William Crookes discovered cathode rays when he was studying electrical discharge in gases, whereas J.J. Thomson discovered that the cathode ray consists of negatively charged particles called electrons. Production. Cathode rays are produced in a discharge tube. Hence, the discharge tube is generally referred to as the cathode ray tube. The cathode ray tube is a partially evacuated glass tube with cathode and anode placed at the ends of the tube. A vacuum pump is used to partially evacuate the tube. The cathode is connected to the power source with the help of a clip. The tube is supported on a stand. It was found that electric discharge through gases took place only when the pressure inside the tube is lowered and the potential difference between the electrodes was high. To produce cathode rays, high potential difference of 10 kV to 20 kV is applied between the electrodes and the pressure is reduced to 0.0001 millimeter of mercury by means of a vacuum pump. A glow is seen on the walls of the glass tube. The bright fluorescence glow is due to the striking of the rays emitted by the cathode. These rays are cathode rays. Properties of cathode rays. Cathode rays travel in straight lines. When an opaque object is placed in the path of the cathode rays, a shadow is cast on the glass wall opposite to the cathode. This shows that cathode rays travel in straight lines. Cathode rays consist of negatively charged particles. The rays deflect towards the positive plate when the tube is exposed to an electric field. This is because the negatively charged particles in the cathode rays get attracted towards the positive plate. Cathode rays are deflected by the magnetic field. When the tube is exposed to a magnetic field, the cathode rays follow a curved path showing that they are deflected by the magnetic field.
So, as you saw in the video, that William Crookes was the scientist who did an experiment with gas, and that experiment was known as discharge tube experiment. And it was further studied by J.J. Thomson, in which he discovered that when the electrodes of that discharge tube is connected to a very high voltage source, a rays start originating from the cathode. What is cathode here? The electrode which is connected to the negative terminal of the battery. And from there, he observed that a ray start originating and travels towards the anode. And that rays, when he studied that properties, he discovered that it consists of negatively charged particle, and those negatively charged particle, those rays he named as cathode rays, and those particles present in that cathode rays he named as electrons. Further, the same experiment was studied by Goldstein, and he observed just opposite ray that originates from the anode. In that same discharge tube, Goldstein observed not only a ray is traveling from your cathode towards anode, but at the same time from anode also another bunch of rays is originating and traveling towards the cathode. And by studying the properties of the rays originating from the anode, he observed that those rays were positively charged, and he named the particles present in those rays as anode rays, or otherwise known as canal rays. Let's watch another video to understand how anode rays originates in discharge tube and how proton were discovered by Goldstein.
Canal rays. Canal rays are beams of positively charged ions produced in a discharge tube. In 1886, the German physicist Eugen Goldstein discovered canal rays and experimentally proved the existence of protons in the atom. Goldstein used a discharge tube containing air to low pressure. The tube had a perforated cathode at one end. When voltage of about 10,000 volts was applied to the discharge tube, a beam of rays was generated at the anode and passed through the perforated cathode. Because these rays passed through the perforations, the canals of the cathode, Goldstein named them canal rays. Since the canal rays are generated at the anode, which is the positive electrode, they are known as anode rays or positive rays. When the canal rays struck the walls of the discharge tube, they produced a faint red glow behind the cathode. Let's see the mechanism of the formation of canal rays. When the high voltage passes in the gas, the atoms separate into negatively charged particles and positively charged particles. These positively charged particles pass through the gas towards the cathode.
So dear students, as you saw in that video, that how your protons were discovered from discharge tube experiment. There also you saw that your anode rays is also known as canal rays. Why is it known as canal rays? Because in that experiment, Goldstein had taken a cathode having holes or canals, perforated cathode. As the rays originating from anode passed through these holes or canals. That's why he named it as canal rays. And canal rays, otherwise known as anode rays, consist of positively charged particles known as your protons. So discoveries of these two particles, electrons and proton, led the path to understand how a particular atom behaves and how is it different from another atom. And because of this discovery, there was lot of theories and models were discovered in order to explain the structure of an atom, how these particles, how these subatomic particles are located inside an atom, and what is their behavior, how they contribute for the properties of an atom. So the first atomic model that was proposed was by J.J. Thomson, and it is known as Thomson's model of an atom. And in Thomson's model of an atom, that you saw that Thomson developed this model from discharge tube experiment after discovering electrons. So he tried to explain that atom is a positively charged sphere in which the electrons are embedded into it. If you try to simplify this statement, all of you must have seen a Christmas pudding, and in a Christmas pudding, or otherwise this model is also known as plums pudding model. In a pudding you must have seen there are plums embedded into the pudding. The dry fruits or dry nuts is known as the plum. The baked part or the cake part, soft part is known as the pudding. So he imagined or he described as an atom as a positively charged sphere, and to it these negatively charged electrons are embedded. And if we try to explain it further in a simple way, if you have seen a watermelon, in a watermelon the red part is positively charged and the seeds are negatively charged. That is how you can visualize as an atom. In reality, the red part is not positively charged or the seeds are not negatively charged, but to understand the model that was proposed by Thomson, we can bring out that similarity, that as atom is a positively charged sphere, in that watermelon also the red part is called as the positively charged and electrons are embedded into it like the seeds are embedded in a watermelon. Let us see another video to understand how we can visualize Thomson's model of an atom.
Thomson's atomic model. Joseph John Thomson, a British physicist, discovered the electron in 1897. Thomson introduced a model of the atom in 1904. According to his theory, an atom is a sphere with positively charged particles surrounded by negatively charged electrons. He also suggested that positive charges are equal to negative charges. The model was referred to as the plum pudding model because one could imagine a plum pudding wherein the pudding itself is positively charged and the plums dotting the dough are the negatively charged electrons. This plum pudding model of the atoms suggested by Thomson was later proven incorrect by Ernest Rutherford, when he showed that the positive charge is concentrated in the nucleus of the atom.
So it is very much clear from the video and we can visualize Thomson's model of an atom. So based on this, we can summarize the postulates of Thomson's model of an atom as such, that an atom consists of a positively charged sphere and the electrons are embedded in it. The negative and positive charges are equal in magnitude, so the atom as a whole is electrically neutral. As we can see from the picture, from the video, that the positive part occupies a lot of space. So obviously in mind we have a question that if the positive charge occupies a lot of space, how an atom electrically can be neutral? There Thomson explained that although the positive charge occupies a lot of space inside an atom, but the magnitude of positive charge is equal to the magnitude of negative charge, which balance each other, although the electrons occupies a little space inside an atom. But later on, another scientist did an experiment which is called as alpha scattering experiment, and it was carried out by Rutherford. When Rutherford did his experiment, the model that was proposed by J. J. Thomson got discarded. And what was Rutherford's basis of experiment? How he described an atom? Let's see the video to understand what is gold foil alpha scattering experiment.
Rutherford atomic model. The Rutherford model of the atom, also known as the planetary model, was proposed by Ernest Rutherford in 1911. According to the model, an atom is a tiny, dense, positively charged core around which negative electrons revolve. This atomic model was an outcome of the famous gold foil experiment. In this experiment, a radioactive source emitting alpha particles, which are positively charged particles, is enclosed in a protective lead container. The radiation was focused into a narrow beam through a slit in the lead container. A thin sheet of gold foil was placed in front of the beam. A circular screen was coated with zinc sulfide to render it fluorescent. The screen was placed in front of the gold foil. When the alpha particles bombarded the gold foil, they passed straight through the foil, indicating that most of the atom is large empty space. Some alpha particles were deflected slightly, suggesting that they interacted with other positively charged particles in the atom. Other alpha particles were bounced back towards the source, indicating the presence of strong positively charged particles in the center of the atom. Rutherford presented the experimental results to describe the structure of an atom. He stated that the atom is made up of a central dense positive charge surrounded by a cloud of orbiting electrons. He did not use the term nucleus.
So, let's summarize what we saw in the video and what is Rutherford's gold foil alpha scattering experiment. And let us compare between Thomson's atomic model and Rutherford model of an atom. As suggested by Thomson, that atom is a positively charged sphere. And as you know, alpha particles are also positively charged. They are doubly charged helium ion. If you take helium atom and remove the 2 electrons from helium, the 2 positive charge on helium is nothing but similar to your alpha particles, which is 4 times heavier than your one single proton or hydrogen ion. Rutherford took a gold foil. Why gold foil? Because as you know, gold is the most malleable metal. That means it can be converted into thin sheets. After taking a gold foil, he allowed alpha particles to fall on it. And he was expecting that, as suggested by Thomson, that atom is a positively charged sphere. So when a positive particle will fall on the atom, it will deflect back. But to his surprise, what he observed? That most of the alpha particle passed through the gold foil without showing any deflection. Some of the alpha particles, they deflected at a very small angle. And third observation was, out of every 12,000 particles, only one alpha particle bounced back, that is making a angle of 180 degree. So this led him to conclude that most of the space inside an atom is empty because most of the alpha particle pass through the gold foil without getting deflected. Second, very few alpha particles were deflected from their path, indicating that the positive charge of the atom occupies a very little space. Third, a very small fraction of particles were deflected by 180 degree, indicating that all the positive charge and mass of the gold atoms were concentrated in a very small volume within the atom, which was quite opposite to the observation or the postulates given by J.J. Thomson. And this was the reason why Thomson's model of atom was not widely accepted. And based on his observation, Rutherford gave his postulates for his atomic model. And what were the postulates? There is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. The electron revolves around the nucleus in a circular path. The size of the nucleus is very small as compared to the size of an atom. So, in his model, what he tried to express that as most of the alpha particle pass through the gold foil indicates that most of the space inside an atom is empty. As few alpha particles deflected at a very small angle, that indicates positive charge is there inside atom, but it is not spreaded throughout the atom, rather it is occupying a very small space inside an atom. And that small space he concluded as the center of the atom, and he named it as the nucleus. And what about the electron? Now the electrons are revolving around the nucleus in a circular path. So this is how he tried to describe about the proton and the electron present inside an atom. But here again, this theory also has a demerit that we call as the drawback of Rutherford model of the atom. What was that drawback? The drawback was it could not explain the stability of an atom. You must be wondering how it could not explain the stability of an atom. That is because, as you know, electrons are charged particle. Whenever a charged particle moves in a circular path, it will radiate energy as well as it undergoes acceleration. As it undergoes acceleration and at the same time it radiates energy, that means gradually with time the path of that charged particle will decrease. That means it will start executing or it will start following a spiral path, and after some time it will jump into the nucleus. And as you know, as per Rutherford model of an atom, the nucleus contains positive charge and the electrons is negatively charged. So positive charge and negative charge will discharge each other, which will lead to the instability of an atom. That means if you follow the postulate suggested by Rutherford, atom does not exist, which is not true because we live in this universe which has an existence. So that was the drawback of Rutherford model of an atom. Again, this drawback was overcome by another scientist, which we will study in the next class. Let us now see whatever we have studied. So what we studied today? First, we studied about the presence of subatomic particle inside an atom, like electron, proton and neutron. Then we discussed about the discharge tube experiment, where these electrons and protons were discovered. Today we discussed about two atomic model. One is proposed by J.J. Thomson and another one was proposed by Rutherford. Now dear students, let's test what we have understood through some questionnaires. So I am putting some question in front of you. Try to answer it honestly. The first question for you: what are canal rays? I know you all can answer it. The answer is that canal rays are originating from the anode in the discharge tube and which is also known as anode rays, which is positively charged. Another question for you. If an atom contains one electron and one proton, will it carry any charge or not? I think you can also answer it, and the answer is it does not carry any charge, because one proton and one electron will cancel out each other. Hence, the atom will be electrically neutral and it will not carry any charge. Another question for you. On the basis of Rutherford model of an atom, which subatomic particle is present in the nucleus of an atom? We had studied about it also. Let's see what is the answer. The answer is proton. As suggested by Rutherford, nucleus of an atom consists of a proton. So that's all for today. We'll continue in our next class about the other discoveries and other atomic model proposed by eminent scientists. Till then, take care. Thank you.